Assalamualaikum and hi everyone. In this video we will be looking on chapter 3, which is torsion of solid and hollow circular section. Before we begin more details on torsion, let's go for definition. What is actually torsion? This is an example of structure when subjected to torsion. From this figure, we can define that torsion is the twisting or wrenching of a body by exertion of force tending to turn one end or parts about a longitudinal axis, while the other is held fast or turned in the opposite position. In this session, we are going to learn two things. First is the parameter involved in torsion, and the second is types of structure subjected to torsion. Okay, first, there are two important parameters that we want to know. First, what is the maximum shear stress occurs in the structure, and how much the angle of twist occurs when subjected to torsion. Why these two parameters are important to us? Because there are critical point or critical condition where the structure can support. If the torque applied on this structure will create greater shear stress than the maximum shear stress of the structure, then the structure will fail. Same goes to angle of twist. If the angle of twist created from the applied torque is greater than the allowable angle of twist of the structure, then the structure will fail due to torsion. Maximum shear stress due to torsion is given by the equation of tau max equals to Tc over J, which tau max is the maximum shear stress, T is the internal torque at a particular section, C is the radius of circular section, since we only learn about torsion of cylindrical bar or rod, and J is the polar moment of inertia. Since our structures are solid and hollow sections, then we will be having two formulas of J. For solid circular section, J equals to half pi times C to the power of 4. As I mentioned earlier, C is the radius of circular section. As you can see in the figure, the shear stress is varies directly from the center of rotation to the surface of structure, and the maximum shear stress occurs at the farthest point from the center, which is at the surface of cylindrical bar. For hollow circular section, J equals to half pi times C outer to the power of 4 minus C inner to the power of 4. Look at the figure here. We can calculate the minimum shear stress by using equation of Tc over J, but C in the question must be replaced by C inner. Then how to determine the internal torque? In the formula of maximum shear stress, the T used is internal torque of a particular section. Let's say this is the cylindrical bar consists of three sections. The first section is at the right or at free end. The middle is the second section, and the fixed end is the third section. This cylindrical bar is applied with two external torques, which are TA at section 1 and TB at section 2. To find the internal torque in section 1, we have to cut the section 1 out. Then we put back the TA as the applied torque, and we put internal torque at the cutting point. In this case, we noted the internal torque at section 1 as TA. Then we put back the TA as the applied torque, and we put the internal torque at the cutting point. In this case, we noted that the internal torque at section 1 as T1. The direction of T1, we just assume it in any direction, but it is easier to use right hand rule, where the thumb is outward from the cutting point. Then the direction of the other fingers is represent the assumption of internal torque direction. Same goes to section 2 and section 3. Every time we cut the section, it's not just consider that particular section, but we have to consider all sections start from the end of the structure. The value of internal torque can be determined by applying the static equilibrium equation. If we get the value of internal torque as positive value, means our assumption is correct. But if it is negative value, the direction of torque should be in opposite direction. The details of calculation will be shown in the next video. The second parameter in torsion is angle of twist. The formula of angle of twist is phi equals to TL over JG, where phi is the angle of twist, T is the internal torque at a particular section, L is the length of a particular section, J is the polar moment of inertia, and G is the modulus of rigidity. Internal torque and polar moment of inertia here are the same as used in the shear stress formula just now. For modulus of rigidity, normally it is given in the question. If not, you have to refer in the table in the textbooks. The unit for angle of twist is in radian. It doesn't matter if we get the negative value, because it represents the rotation angle of the cylindrical bar is opposite to our right hand rule. Then how to calculate the total angle of twist if the cylindrical bar is more than one section? It is simple, we just total up all the angle of twist of each sections. But it is important to assume the internal torque using right hand rule, because it is effects plus or minus during total up the angle of twist. I think that's all for the session. Thank you.